rest of this unit with rational expressions. Now, a rational number is a number that can be written as a fraction. So, since we are working with rational expressions, this is an expression that's a fraction that has a polynomial in the numerator and the denominator. So that means you're going to have a fraction with x's in the numerator and x's in the denominator. Today all we're doing is simplifying. We're not going to add, subtract, or anything like that. We're just simplifying, and we're going to do that by factoring all the polynomials and canceling things off. Right? So if you can factor and you can cancel things, you can do today. Let's jump right into it. 9x squared minus 2x over 9x minus 2. So let's start with the numerator. Can I factor the numerator here?
Oh, yeah.
I can. What comes out of the numerator? An x. So I pull an x out, and I'm going to be left with 9x minus 2. And then I rewrite the denominator over 9x minus 2. Now, what is going to be able to cancel here? Yeah, the 9x minus 2 and the 9x minus 2. And you are left with, you're right, just x. That's the whole expression. Great. That wasn't too bad, right? Number 2 is actually the one that I had graphed right here. So this is the graph for number 2, which you'll do next year in pre-calc. But what we do in number 2, does the numerator 3x factor? No. So we'll leave 3x the same. How does x squared plus 6x factor? Pull out an x. So then I'll have x plus 6. What's going to cancel here? Hold on. I can only cancel things with the multiply. So here I could cancel this x and this x. But because there's a plus sign here, I'm going to leave that as x plus 6. The reason I have to do that is because you remember earlier this year we did that algebraic atrocities worksheet. And we said you can't cancel things like fractions like this with a plus in the denominator because the plus is blocking you from that. You could only cancel if that was multiplication. Since it's addition, that's as simplified as you can go.
Because it's, since it's, what's it called? Division. That's the word. What? Because it's division, is that why? That's
Yeah. It's just one of those rules of math. Inverses. Yes. Here I can cancel because the x is being multiplied by the factor. And these are also being multiplied. You can only cancel things with multiplication, not with addition.
So if the top was 3 plus x, you could have done 2.
Right. Alright, we'll see more. Don't worry. Alright, x squared plus 7x plus 12 over x plus 3. Can the numerator factor? Probably. Otherwise, there'd be no point in giving this problem to you. So, I need to find two numbers that multiply to 12. 3 and 4, yeah. So I have x plus 3, x plus 4, over x plus 3. Now, here's a good hint. In these kinds of problems, if you see the denominator has an x plus 3, more than likely, your numerator will also factor to have an x plus 3. Because I can now cancel off x plus 3 and x plus 3. What are you left with? X plus 4. And that's it. It was in the numerator. Okay, let's look at number 4. 8 minus 2x over x squared minus x minus 12. What can I pull out of the numerator? A 2. So if I pull a 2 out, I'm left with 4 minus x. And I have to factor two numbers that multiply to negative 12 and add to negative 1. Yeah, negative 4 and positive 3. Now, can I cancel anything? No. Ooh, look at these. These are close, but they're not the same because this could be rewritten, this 4 minus x. You could rewrite that as negative x plus 4, which is really close to what I have. Can you guys think of a way, though, that I could make it so I can cancel those off? If I pull out a what? A negative 2. 2. Let's do. So actually what you're going to do is instead of positive 2 from the numerator, let's factor out a negative 2. Because when I factor a negative 2 out, I'll be left with negative 4 plus x, which, if I rewrote that, that's x minus 4. And notice that's going to now cancel with the denominator. So if you're really close on one, you might want to pull out a negative 1 or a negative GCF because now I can cancel and cancel. What's my numerator of my answer? Negative 2 over x plus 3. And that's it. That's probably the hardest one on the page. 2 more. X squared minus 9. How does that factor? Difference of squares, yes.
Sorry, I like this.
Difference of squares. And then the denominator, x squared minus 6x plus 9. Two numbers that multiply to 9 add to negative 6.
Negative 3.
Negative 3 and? There you go. Well, again, I can cancel my negative 3's. So what I have left here is going to be x plus 3 over x minus 3. Can those simplify anymore? Oh, but I have pluses here. Can't do it. That's it. That's as far as I can go. Because what's actually going to happen next year in pre-calc, you'll factor, you'll simplify, you'll get this x plus 3 over x minus 3. The numerator and the denominator here is going to tell you where you have asymptotes. There's going to be vertical asymptotes, horizontal asymptotes, and then what they call oblique asymptotes, which are slanted lines. So once you do all the factoring and canceling, it's going to help you find all the asymptotes, and you can make the graphs.
Great.
Yeah, things to look forward to. Super fun. That's actually my favorite thing they do in pre-calc. All right, last one here. Let's factor the numerator. Two numbers that multiply to 10 and add to negative 7. Negative 5, negative 2. All right, the numerator is quick. Let's talk about the denominator. Now, I know this is no calculator unit. The numbers are not going to be that bad here. But 3 times negative 35. I'll give you a hint. It's negative 105. So I need two numbers that multiply to negative 105 and add to negative 8. Negative what?
7 and 1.
Negative 15 and 7. Yep. Kaylin. Well, you could sit there. You know what I did on one of the problems on the back is I did long division. Because I did it without a calculator, so I sat there and went, okay, 105 divided by 5. Didn't work. 105 divided by... That's what I did. Well, if you had a calculator, it wouldn't really help you that much with all the factoring stuff anyways, so... Other than that.
Well, but you can do that sheet where you click it in and then you divide it by x and it's
You could.
What? Yeah.
Alright, so let's factor this. We're going to do split the middle here. So I have 3x squared minus 15x plus 7x minus 35. Real quick, we're almost finished. I do split the middle. I pull out a GCF of the left one of 3x times x minus 5. And my other GCF is 7. You should see a good thing here because when I have 3x plus 7 times x minus 5 is something going to cancel. It sure is. X minus 5. So your final answer here is x minus 2 over 3x plus 7. All right, not too bad today, right? Tomorrow we'll bring in a multiplication and division and things. I would like you to do the practice on the back. The answers are not on the bottom, but the key is on Canvas, and I'll also have my key up here, or I'll walk around with it so I can check. Actually, I want to talk about number 3 real quick, because number 3 will help you with another one later on. Or actually, number 5. I'm going to skip to number 5. Let's look at number 5 real quick, because there's one thing that a lot of people were making this common mistake. So number 5, the numerator stays the same, 4 plus x. How does the denominator factor? It is difference of squares, but notice the numbers in front, so be careful here.
4 minus x, 4 plus x.
Yeah, 4 minus x, 4 plus x, okay? So the factoring part's not the tricky part here. We can cancel the 4 plus x's. Now, when I write my answer, when I cancel something out of the numerator, the 4 minus x is still in the denominator. It's not 4 minus x is your answer. What has to be in the numerator here? A 1. Right, a lot of people were forgetting the ones in my 7th period. Right, so you're going to keep the numerator as a 1 if you cancel out the term. Okay, so that would be your full final answer. Go ahead and try the other ones. I'll come around and help you, work with you.
So I